Good afternoon, everybody. Jason here from Meridio, and in today's webinar, we're going to be talking to Steve Shaw from Light Illusion, and we're going to be looking at the new color space display calibration software that they've developed over at Light Illusion. We had a session this morning where we did a lot of Q&A and just a kind of an introduction, and the point of this session this afternoon is we're going to dive a little deeper into the software and actually look at some live demos, and Steve's going to show us all the great things that that color space is known for and all of the great features that it has to offer. So with that being said, Steve, are you there? Can you hear me?
Yep, indeed. Hear you clear.
Cool, Steve. So sounds good. So thanks for joining us this afternoon. And just in case anybody is joining the afternoon session that maybe missed the morning session, do you want to give everybody just maybe a quick explanation of who you are, where you're from, and where Light Illusion came from?
Yeah, sure. Obviously, Light Illusion's been around for some 12 years or so. It evolved out of my need for color management when I was doing grading work myself on feature films. My history before that's been with a manufacturing company, Quantel, in the early days of digital television. Had a couple of post houses, Men in White Coats and Axis Post, doing VFX and all that kind of stuff. Moved into grading, went freelance, and kind of from there we've ended up here, I think is the short version.
That's great. That's good. The color grading folks, I love meeting those guys and girls, because that is such a it's such an art, you know, making the movie look how it's supposed to look at the very end of it all. It's a very, very cool skill to have, and I love watching the behind the scenes of movies and seeing how all that stuff's done. It's very fascinating to me. So I'm really glad to have you on and hear some of your perspective doing more of the professional work. This is really, really, really cool. I'm glad that you're here.
No problem.
Yeah, good. So guys, with that being said, what we're going to do here is I've got a LG 55C7 behind me. We're going to use this Klein K10 colorimeter, and we've got a Meridio 6G generator here putting the test patterns on the screen. So what we're going to do today is we're going to take a look at the color space software, and Steve's going to kind of walk us through some demos and show us all the great features and some of the functionality that it's capable of. So with that being said, I will go ahead and share my screen. And if any time, guys, if you have any questions about anything Steve's talking about, feel free to type any questions into the question box, and I'll do my best to kind of field those as we go here. And then we will leave some time at the end in case we missed any of the questions in the middle. So don't be shy, guys. This is for you to kind of see the software, so feel free to ask any questions you might have. So Steve, can you see my screen now?
Yep, got it.
Fantastic. I'm going to hand over the mouse to you.
Okay.
And you should be good from there.
Okay, that looks like we got it. Okay, so if we open up color space, we'll just go through a kind of a basic overview of the various functions based on the icons and what have you. And if people want to ask questions of any specific area, then as you say, they just type them in and we can jump into them, because there's no structure here. It's all a bit free flow. Anyway, the first three icons that you see on the main pop-up page are a library for color spaces, profiles, lookup tables, gives you a bunch of management tools as well. The profiling icon to actually profile, which means to measure and record the parameters of a display, and then the LUT tools at the end for generating the calibration lookup tables, LUTs and all that kind of stuff. So if we open up the managed spaces, it really is just a library. So if we just open it up slightly, we can pop into profiles here, which is where profiles that we've made previously actually appear, so we can actually reopen them, look at the data, all the rest of it. We have color spaces, which are the likes of Rec709, sRGB, all that. So effectively matrix based. These ones are user generated, which we'll come back to. In fact, I'm going to just delete that one because we'll come back and look at that in a bit for a particular reason. And then we've got preset color spaces. In this case, they're film emulation, so we can actually generate LUTs to emulate film stock profiles. And then this is our preset spaces for the various standards that the system works with. So if we, for the minute, ignore those and look at starting from scratch, if we open up the profile window, we should get, there we go, the basic heart of the system, which is the ability to plot data that is measured from a display using attached hardware. So on the left here, we have different ways of viewing the data once it's been acquired. So we've got at the minute an XY diagrams, a bit of delay on the cursor. Come on, update, here we go. UV, volumetric, EOTF, and so on. So we'll start with the UV, and if we were to attach to a probe, we will go for the Klein because it's the one that's connected. Port 6, and then and we have various options of controlling settings for the attached probes depending on what they are. And for hardware, we're on the Meridio 6G in amongst all the other hardware we have available, COM5 Connect. And then again, we can set the patch size. So we'll just go for a medium size rather than anything specific. That'll do the job. And then when we go into the measure window, now I can't see where you've disappeared to, Jason, so I can't see the monitor behind you.
I'm here. I'm popping the camera back up right now.
Otherwise, I can't see what's going on to make sure the patch is in the right place. There we go. So if we now change the sliders, you can see that behind Jason there, the patch window is following the various settings that we set here. And if we take a measurement, then we will see that it will pop up the value as measured, and it's just down there. We don't need that window there. We can get rid of that one. And you can see there that we have that measurement with a tangent line associated with it at the moment. At the moment, we are expecting a target of 0.8 nits luminance, but we're over 1 nit. Why? And that's because the black and white levels haven't been set for this particular display. So what we'll do is just auto those, just because it's a bit easier. And you can see the green bar on the bottom tells us it's doing the measurements, and it's now updated the min and max values for this particular display. And now you can see that we're a little closer in the range. Let's go out a percentage. You can see that we're just slightly over. And again, that's based on obviously the gamma value not being quite right. But here you can see the relative red, green, and blue with the luminance and the resultant delta E. You can look at it in chroma only as well, which ignores the luminance error. So that shows us that the error in this instance is predominantly luminance, and so on. Anyway, that enables you to obviously take as many individual readings as you want, and it will build up the values on the graph as you take each individual reading. A better way of doing that would be to use something like a preset list. And oh, where have we gone?
Steve, let me grab.
Help me out there.
Scroll up there.
Oh, was it on that one?
And then desktop.
Okay, got it.
And then the first folder.
It's in that one.
There you go.
Good. Oh no, it's not. That's the actual software folder, so it won't be in that one.
Oh, you're looking for that spreadsheet.
Yeah, the CVS file.
Yeah, give me just a second,
okay.
And I'll grab that for you.
Okay, that's all right.
I just gotta remember where I put it.
Or CSV file.
And you want me to just put that on the desktop? Would that be
easiest?
That'd
be fine, yeah.
Okay, great. Give me just a moment.
That's okay. But it is just a comma-separated variable file with a list of color patches in it, so that we can actually use any user-defined sequence as a way of profiling in this manual measure mode. So this obviously, there we go. So if we just open that up.
Yeah, you can take the mouse now.
Yep, got it. There we go. So we'll just populate those colors here so that we have a list of the colors in this particular instance. We can go through them at any point and just literally select them and do a measurement, and it will pop up the measurement on the graph. Or more importantly, we can automate it so that when we measure, it will cycle through that list. If I go into the manual, you'll see the sliders responding.
Steve, I have to say the speed of the program is very impressive. It's very snappy.
Yeah, a big part of the rewrite has been to clean up, obviously starting from a new code base, so there's no kind of overhead in the system whatsoever. I mean, the program size is very small. You know, even with all the graphics and everything it has, we really have got a very clean program. Obviously, it helps that the Klein is a particularly fast probe, so that helps
Exactly.
speed through the measurements.
Yeah, yeah. The
See
doing
it
like a
builds up the graphs at the same time. Now we can pop around the graphs. I mean, we've just been looking at that particular one at the moment, but if we go to any of the others, they're all live at the same time. And if we go into the volumetrics, is where it gets more interesting, which is where we can actually see the profile data in true 3D space. And we turn off the tangents for the minute. Oh, delay can be a bit. There we go. So you're now just looking at the measurements that we've just made in their relative position in three-dimensional space. And the color coding tells us the level of accuracy or not of the profiles compared to where they should be. And if we turn the tangents back on, they actually show you the direction of the error. So at the moment, let's have a look. We are targeting Rec 709. I reckon if we go sRGB, okay, the errors get worse. So in this instance, if we look at the gamma, then yeah, we can see there that well, actually I hit P3, not sRGB, because of the delay. There we go. So that's sRGB. If we go back to the volumetric, the errors are smaller because the gamma of that display is closer to sRGB, as in 2.2 gamma, than it is to 2.4 for Rec 709.
So Steve, if you look at the cyan reading right now, it's kind of in the upper left. The actual little cyan block there, is that the target or is that where it measured?
No, the target in this instance is, sorry, the measurement is always the dot,
the red dot.
Dot.
Perfect.
Because this is a pure secondary color, it has a colored dot as the target. So Excellent. This is showing you that the error is both a major luminance error, but also a minor chromaticity error because the tangent isn't totally vertical.
Correct. Good. Cool.
If we go over to the options again, we have this thing called target only. And what that will do is swap it around. So now the point is the actual where it should be. So the triplet value of the patch, and the tangent now shows you where the point actually is. So we've inverted. So if you watch the dots, say on this line here, as I hit target only off, the dot moves to the other end of the line. So it's just another way of showing what the error actually is. Excellent. Obviously, we've only got a few points here, so the amount of information is relatively small, but we can zoom right into it to actually see any level of detail that we choose to in the various points in the graph. More interestingly, if we switch that to RGB cube, oh, wrong one, not RGB, the delay can be slightly awkward, and zoom it back out. You can now see the errors in true volumetric space normalized. So now you can see that the errors are greater in certain areas than they are in the middle. So this is just helping to display the errors in a much more visual form than the CIE diagram can. So obviously, if it was correct, the points would be forming a perfect space in a cube. So they'd all be very, correctly centered. If we were to do that with something slightly different, if I just close that one down, and we actually look at an existing profile, you'll get the idea. And in here, we've actually got, come on, there we go. If we look at this, for example, Pure Rec 709, this is a synthetic profile, but it will show you what I mean in that, oh, yeah, there we go. In that now, if we go and just set the luminance to be correct, you'll see that the points, and this is Rec 709, not sRGB. Oh, come on, there we go. Right. The points are all green because it's a perfect profile of a perfect display. And if we look at it in the cube, you can see that obviously the cube is perfect. So very quickly, with any profile, you can tell if the display has any non-linear volumetric issues because it will be a non-cubic representation. And if we look at the CIE diagrams now, you can see that they are going to be again, what you would expect for a pure display that is 100% accurate.
On that profile, Steve, how many points did you read? Do you remember?
Yeah, they're 21. So sorry, 21 cube 3, so 9,600 and something.
Very cool.
Yeah, I mean, there isn't really a limit to it for the system itself, but the limit comes into how long it takes when you're doing it for real. You know, with a Klein K10 or a CR100, something like that, you're looking at an hour, hour and a half to do a 10,000 point profile. But we've got, you know, kind of tools built into the system to deal with the issues you may have, like drift and overheating. So we've got stabilization patches, we have drift patches, things like that that will help with the longer profile times. But to just go back to showing what that really means, if we go back to our library, this Convision 21 cube, so here we go, with drift profiles, so drift patches in the profile, so we can have a look at that separately. But what I'm going to do is modify this profile and do something called an extraction. And what this will do, if I just call it ext so we can see it and go extract space, it will take that profile and extract from it the color space of that display in its raw native state. So we're no longer saying, is it Rec 709, is it sRGB or HDR? We're just saying, what is it compared to its own raw measurements? So if we now look at that, double click it again. Come on, open up. There we go. Right, if we look at that now, and again, just stick the actual minimum maximum from the display, when we look at the cubic display, I'm going to turn the tangents off for a second, and we look at the cube, you can now see what inherent issues there are with this display, because the color space is mapped to the primary RGB values and the black and white, and the fact that the dots are in some areas outside the cube means that in those areas the display has too much gamut, and where it's inside it lacks gamut. Now this looks big. The cube effectively normalizes any inherent EOTF, any gamma. So where you are down in the shadow area, you will see a greater error than you would in the highlights, because we have normalized the gamma out very deliberately, because you need to see more detail in the shadows than in the highlights. So here we're just seeing that the display cannot make blue when mapped to itself. And if we, oops, sorry, he says map to himself, he's forgotten to do that one thing, just map it to itself. That is compared to Rec 709. Let's map it to itself, which is what we were intending. There we go. That's better. Right, so now you can see the errors are less, but you can see they're non-linear. It's got these kind of
curves.
Yeah, exactly. So that's where the volume, the color volume of the display isn't actually meeting what the primaries and grayscale are. So it gives you a very good indication of the inherent issues with the display. And the minute you see this curvature, anything like that, it's a non-linear volumetric error. You know that you're going to have to use a 3D lookup table to correct it, because you cannot correct it any other way.
Steve, do the color of the dots here indicate anything, like closer, further?
Yep, absolutely. The green dots mean that the error is a delta E value of less than 1. Orange means they're between 1 and 2.3, because 2.3 is the just noticeable difference threshold, and red means they're greater than 2.3.
There's a couple green dots in there. There's a few.
Yeah, there's a few. There's a few. If we look at the two-dimensional diagram, then you can see a little easier where the errors are, and obviously, you know, certain areas are more accurate than others, and you say the odd green dot. But it's interesting that, you know, this is a display that's being mapped to itself. So it shows you that, you know, the underlying issues with any given display. This isn't a particularly bad display at all. In fact, it's actually quite a good display. If you were to do this with the LG behind you, it would be way worse.
Yeah.
So, you know, it's just, that's the way displays are. But again, if we want to just take another look at stuff in more detail, if we actually just double click any point in the CIE charts, we get a little pop-up window that will give us information on the particular patch that we've chosen, giving you, error information on it and the actual colorimetry used. This will be expanded to have a lot more information as we move forward. But again, you can obviously see a lot of the inherent issues. And again, if we turn those tangents back on, then you can very visually see, wrong one, where the errors themselves are. And you can see there's a bit of a pattern going on, which again helps analyze what it is that's going on with the display itself. And of course, we can zoom right into these things to really see particular given areas. And then if you want to go further, you can do things like, I only want to see the green points. There you go.
Just the green measurement, sure.
See, just the green and orange, just the orange and so on. Or we can actually do filtering. So we can say, I want to see what errors are in the range of 2.5 to 3 and so on. So there's a host of tools built into the systems to give you, a relatively high level of control over assessment of the display.
And that was which display again? Do you remember?
This is a Convision Professional display. It's an IPS display for broadcast. Right? It's not. This particular one is one of their broadcast displays rather than one of their grading displays.
Gotcha.
But it's pretty standard for that type of display.
Sure.
We mentioned drift earlier. This is the drift graph, and what this means is that we sent a high white value patch, probably about 95% white, to the display every 10 patches, and this plots that drift so that you can see how the display probe combination was dealing with stability over time. And then we use that data to build the lookup table, so the lookup table is more accurate.
It's every 10 patches. Is that about normal to set that?
You choose that yourself.
Cool.
Again, if we go into characterization, for example, let's just kill that out. You can see here that we can do what we call quick profiles of different types. They're just preset quick profiles. Users can define their own using any CSV. If we use cube, we can then set the size of the cube, and the size defines how many points. So for example, a 5x5 cube is 125 patches. If we then wanted to do drift every, say, 5 patches, then we get 151 patches. And then again, if we obviously take that up to the full 21 that we have at the moment with a drift of 5, we're at 11,000 frames.
Oh yeah.
So you can set whatever. To go along with that, we have a thing called stabilization, which inserts another patch, this time after every patch. The idea being that displays that suffer overheating or ASBL, that kind of thing, ABSL, you can put up a black patch or a dark gray patch that will help either cool the display down, or more importantly, deal with any image retention from the patch before. Great. So so there's a bunch of different things that all get applied in there. And then again, when we are happy with these setups, come on, click. Okay, it's in. Let's go to there. Right, we can literally say, right, that's what we want to do. Let us connect back to your Klein, and at the same time to your, come on, connect, thank you, to your Meridio 6G. Again, I'll put that just onto medium patches. I mean, patch control, if we want to be more precise, go into, off into automatic. There we go. And we can define patch size and all the other background colors and all the rest of it from this menu. So we can say do a L40. So there we go, whatever. Change the background color, or if required, we can use an ASBL configuration and so on. Okay, and then when we're into the profiling, if we then just literally click start, then it will now start to build up the profile, measuring the patches, putting a black stabilization patch after every patch, and a white patch every 5 frames.
Sure. Steve, while that's running, looks like we may have a question already.
Okay.
Thank you guys for that. And keep in mind that question box is wide open, guys, so feel free to ask away. Michael says, will the extraction help the smaller gametes like the JVC reduced gamut when not using the P3 filter?
Yeah, it means that with JVC projectors that are trying to work into something like Rec 2020 color space, unfortunately JVC don't offer a native mode. They attempt to map the gamut the display has into Rec 2020, and it's almost impossible to disable it. So you need to extract a color space slightly smaller than that gamut, so that you can use the subspace capability, which is activated by this target space here. And the extraction will enable you to get a much closer approximation to the color space you need to aim for.
Good, very good. And only question so far. So cool. Thanks for that question. Very good.
Anyway, you can see that that's now building up the profile, and it does the same in things like the gamut. Oh, obviously, we have a huge luma variation here. So just okay, we haven't seen, because I didn't do the black patches first, we don't have that level, but we can obviously just give it something that's going to be higher. So let's stick 200 in there and see what that does. Yeah, there you go. It's a little bit lower. So it's now building up the profile as the patches go through. We're using what we call an isometric patch set, which means the power requirement of the patches is balanced as much as possible to try to overcome ASBL type issues and heat and what have you. And again, down here, we can see it's slowly building up. And if need be, I can't see.
Oh, the progress bar, yeah.
There you go. Exactly, which we can pause, and it shows you that it's done that much of it, and so on.
I love that you can pause it. There's been times where I've been doing a 1,000 or 3,000 point lookup table, and like, oh, I wish I could pause right now. I need to do something else real quick. That's good. Good feature.
Yep. So yeah, well, that was in Lightspace, so we've carried that across as well. So obviously that would just sit there now and do that, but on the basis I don't think we want to let it all go all the way through on that. We'll abort that. What we can do, just to prove it quickly, is if we do a smaller patch set. So in fact, I'm going to sorry, click that one. There we go. Just do a smaller cube. So let's just do I don't know, 5 by 5. It will give us an idea to play with. A bit of lag. There we go. That'll work. That's good. Start that. It'll erase the original data and start again. But this time, we'll just let it build up because it's going to be a little bit simpler, and shouldn't take too long, as we can see from the thermometer down the bottom.
Yeah, that was 151 readings. It's going to take.
Yeah,
so
exactly.
Pretty quick.
So, and again, while it's doing that, it will build up the other graphs. The gamma, again, we've only obviously done one grayscale, so it's not plotted the rest of the EOTF in yet. But all the other plots that will build up as we move forward.
I love that you can see it happening live in multiple charts and in multiple dimensions even. That's very cool.
Yeah, you will be able to have multiple graphs simultaneously as well. We just haven't activated that bit of the code yet, but you will be able to see 4 or 5 graphs simultaneously.
Oh, without going over here and clicking on each one.
Yeah, exactly. I mean, you can, at the minute, you can obviously run multiple things. So while that's doing that, then you can obviously say, okay, well, while it's doing that, let's go look at something like, I don't know, that one there. So we can open up other graphs and do other things at the same time.
Nice.
We can even connect to different probes, and I could start another profile here while that one's working there.
That's interesting.
So there's a lot of flexibility going on here.
So if I'm in a studio environment, I've got 2 monitors next to each other, and I happen to have 2 pattern generators and 2. I could run 2 sessions at once here, kind of. It sounds like.
Yeah, absolutely. Yes.
Very neat. Especially in a studio environment, you might have 6, 8, 10, 50 displays to work on.
Yeah, so long as you've got independent patch generation capability, then that will work. You've also got a lot of additional tools to back that up. So we've not looked at things like, active LUT here, for example. That means that you can pre-validate a lookup table before you actually use it to make sure that there's nothing stupid going on. you can do things like probe matching. So obviously we tend to do, well, that probe's busy, of course. So if we just go to the virtual probe and connect to that one, and then we can configure here. So we can actually do probe matching using either the standard 4-color matrix method, or more importantly, the volumetric probe matching that we have in Lightspace, which is the ultimate when it comes to probe matching. So yeah, lots of different tools built into it. Anyway, there we go. That's kind of finished. Let's just put that back. And then from the data we've got here, now I can tell straight away that we've had a couple of hiccups, and that's, I forgot that we have a slight bug in the code at the moment, that if I try and do too many other things, it causes a time differential between the patch and the probe. Forgot about that. That is being fixed literally today. But nevertheless, that's now finished our profile. Once we've got it, we can, oh, let's not do that. Let's save it before we do that. So in the graph options, and just save that profile and just call that AV Pro. There we go. So that will now appear in the library.
Oh, there it is. Yep.
Yep. So again, we can double click it. It will go back to it, so we can mess around with it again. Look at the information. But more importantly, if we go into the LUT side of things, we can now use that with anything else to generate a lookup table. So say we're targeting Rec 709. We want the AV Pro data. We will use drift compensation, new LUT is good enough. I'm just going to hit create, and that will go through that data and build us a lookup table. Now the chances are it's not going to look quite right because the error that I could see in that profile, but it will still build as good a LUT as it can, because we're using drift and because of the error in the data set. It's going to take a while to work out the best compromises to generate a LUT, so it may take a little longer than it should.
There's actually a question while that's going.
Okay.
Oh, a couple questions. Kevin says, does the software have a meter profiling feature?
Well, that is probe matching, yes.
Right, probe matching, great, good.
Yeah, and again, the volumetric probe matching that we have is leaps and bounds ahead of anything else.
Michael says, does it give an estimated time of completion? I think he's referring to the progress bar at the bottom.
Yep. Unfortunately, or fortunately, it's totally variable because it depends on the probe, on the display dynamic or contrast range as to how long it will take. So it is impossible to guesstimate that from the beginning.
Fair enough. And one more for right now. David says, can you have an oh, I think this question was already answered, talking about having different charts side by side. We already covered that. So that's
yeah, it's not in the code at the moment. Within one window, it will be. I mean, as in the code's in there, we haven't enabled it.
Cool. David, if I missed that or anything like that, feel free to just type it in the question box if you need some more clarification.
Okay.
Good. And those are the questions so far. Perfect.
Okay. Well, it looks like this is going to be a right pain to process because of that error. So to be fair, I think I'm going to try and abort that. And that is the one thing we are missing, is a sensible abort button for LUT generation. It should do so. There's always a way around it.
Oh, sure.
Come on. Actually, I must add that to that list. Where's my, what it doesn't have, abort LUT. That's the button. I knew there was a button we were missing.
This is good. See, this is good. And this is the alpha version, right?
Yeah, we are very much in alpha testing at the moment. So yeah.
How far from beta do you think you are?
The aim is to get to beta next week.
Yeah.
So there's a couple of caveats to that, because we are changing the way that the licensing structure works. So that may cause a little delay, but with luck, it shouldn't. The feedback from the alpha testing has been actually better than we anticipated, with very, very few problems. So we are feeling quite confident about that at the moment.
Hey guys, Steve's done an excellent job. I'll grab the mouse from you real quick on the website. actually, you may be better at finding this than I am, of course, but if you want to show the folks, Steve, where that progress bar is at, this is really
Yeah,
interesting,
sure.
guys.
Yeah, on this page, which is the color space page, we have these tabs here, and we are keeping this up to date with information, specifically the development status. So we have got information here as to where we are in the progress of everything. So we're at alpha now, we're very close to beta, and obviously the full release is lagging behind slightly. We will go to full release before we actually finalize everything. So certain features will not be in the initial full release, but there'll be things that are only used by a select few.
Sure.
So it shouldn't be much of an issue, but obviously we will add them very quickly thereafter.
If Steve, if anybody on the call is interested in becoming a beta tester, how do they get signed up? How does that work?
Anybody that has got an existing advanced purchased color space license or purchased light space with a free color space upgrade is eligible to join the beta program.
Very nice.
As soon as we release the program, there'll be an announcement here, and people can use the contact form on the website to request access to the program.
Excellent. I did hear a chime. I think maybe we've got some action down here in the program.
Yeah, it looks like it. There it is. And as you can see, that is a very crazy LUT.
Oh wow, yeah, that looks having flashbacks.
Yeah. That's again, that was my stupidity. I forgot that at the moment all we're lacking is a lockout between the patch generator and the probe and anything else that causes interrupts within the PC.
Sure.
It's there, it's not connected. So at the moment, when an interrupt happens, unfortunately, it carries on trying to read, even though the read isn't valid.
Got it.
So let's just put that back down, because again, what we can do is, because we know that profile's not worked, if we just go and do one of the other ones. So for example, the Convision, whoops, too far. The Convision one that we were playing with earlier. Let's do the 23. I'm going to turn off drift just to make things a little quicker. And this will now generate a Rec 709 LUT from that profile, and you'll see more of what the LUT itself should be, and a little bit more information on what the LUT is trying to correct.
A couple more questions looks like they came in. Let's see. Steve says, can you briefly explain the difference between the two types of probe matching from the perspective? One is a spectro and one is a colorimeter.
Yeah, I mean, standard probe matching, it takes measurements from a spectro and from a tri-stimulus and generates a 4x4 matrix to try to compensate the errors. This is what's called the FCMM method, 4-color matrix method, and that's used the world over and has been for some time. With the advent of displays like the LG WOLED, which is a non-additive display because of the use of the white pixel, that really doesn't work. LG came up with this idea of using 3 different 4-color matrices broken into sections between the primary colors and the white point, and doing 3 different 4-color matrices and joining them together. We looked at that, and it causes issues at the color boundaries. So we decided the better way to do it is to actually volumetrically measure the entire color space, which is basically what we've just done. We've just done a 5x5 profile, which was 151 patches. If we were to do that profile once with the spectro, once with the colorimeter, we can now build a far more accurate probe match algorithm. And that's what we do, and that works amazingly well with displays that have such issues. I mean, again, Flanders Scientific were the first to evaluate this method when we released it. They were blown away by the accuracy. We actually got approached by a very, very well-known probe manufacturer asking if they could adopt the same method because of the level of accuracy. The problem is you can't. It cannot be done in a probe. because of the way that it works. It can only be done in the way that we do it.
Sure, sure. Good, good, good. Another question came in from, let's see, who's
Sorry,
that?
yeah, go on.
Oh, sorry.
Sorry.
Robert says, Robert asks, a brief description of the licensing changes.
The licensing changes are actually very much in followation of the Lightspace licenses previously. The major differences are that we have a higher level license that now incorporates things like Spaceman, Space Match, and Matchlight into the Color Space program. Those additions will actually be additions that won't make it into the very first release. But we have Color Space INF Infinite, which has all of these options. The rest of them are broadly similar to Lightspace. And again, if I just grab the mouse,
yeah,
if we
go for it. Yeah, go for it.
The website, and on the Color Space page, whoops, there we go, we have a features matrix, and that explains the differences between the different licenses. If you hover over the eye, it'll tell you what each option is, and the level of total functionality that's possible. So if we look here, for example, probe options, there are all the probes that Color Space presently supports. And if you hover over where it says limited, then it will tell you just the probes that that particular option has, for example. So the matrix should give you the ability to see exactly what you need and therefore which license meets your requirements.
Great. Yeah, and if you guys have specific questions from here, you can always email Steve and he'll clear those up for you right away. Another question came in and from David. I understand Color Space does not work on Windows virtualized on a Mac, like with Parallels, unlike Lightspace. Any chance that will change in the future?
Well, actually, no. You can see that actually says here, it says the use of a virtualized machine will not be supported. That is our present stance. The reason being that we intend to do a Mac version.
There you go.
It's always been in the plan from day one. I mean, the core code of Color Space has been written to be OS independent. So good. The intention is definitely to have a Mac version. It will not happen at the same time. It will be later in the software's life cycle. By that, I'm hoping it'll be months, not years. But we, at the minute, are struggling with allowing virtualization to be used. The simple reason is that we've had people that are cloning disks to pass licenses around, which is obviously not really pleasant.
Yeah. Couple other small questions came in. Steve asks, we were talking about making the profile before, and Kevin actually asked too, so this is kind of a 2-for-1 here. How long does the 5x5 probe matching take? I would think that had to do with how fast your meters were, right?
Yeah, it basically, like everything, it depends on the speed of the meter relative to the patches that you're using. But a 5x5, which is 151 patches, whatever, no, so it's 124 if you're not doing drift. It really is down to minutes with most probes.
Mm-hmm. Good. And then Steve had a follow-up question on that. Follow-up on the probe matching based on the probe match answer relative to LG WOLEDs. Sounds like it's worth taking the time to measure 125 to 151 patches with the slower spectro. Is there a general delta E between the matrix matching versus volumetric?
Well, matrix matching is only using primary points, so it's red, green, blue, and white.
Right.
It doesn't do any attempt at measurements at lower levels or even within the volume. I can see exactly what LG were trying to do with their approach, because they are just trying to adopt the existing four matrix method, four color matrix method. With the volumetric, even a small volumetric profile will produce inherently superior results. Again, this is not us. This is proven by the likes of Flanders Scientific in all the testing that they've done using it so far.
Good. And then one more, we can move on. Michael says, will the initial rollout support the Lumigen options menu? I believe you guys are ready to rock for Lumigen.
Yep, already in. If we, in fact, if we go look at the, we can come back to that. If we go to, let's open up one of them. Okay, so at the moment, you can see the, come on, there we go. Right, under hardware, you can see that we have got everything from AccuPal, Asus monitors, BenQ, Canon, Dolby, DVD, so on, and Lumagen is there.
Boom. Oh, and then
if we select that,
two down from there is Meridio 7G. I love seeing that.
Absolutely, the 7's in there. So yeah, so when you select your hardware in the drop down, you get in this window the options associated with that hardware. So definitely, if we go to the 7, and that literally was only finished being added today. So again, there you go. So you can see the various options for the 7.
Good, and a lot of folks are excited about that. That's a great piece.
Yeah, well, that was good. We actually got the hardware from you guys only a matter of days ago. And it was actually dead straightforward to integrate. So that happened really quickly.
Great to hear. Great to hear. Let's see if there's any other questions real quick. David says, oh, I think I've got a decent answer for this, but I'd love to hear what you say, Steve. Could you explain why you'd want to have your patches full screen when the probe seems to be only measuring from the location it's at on the monitor?
Yeah, go for it.
So a lot of that, David, has to do with the type of display it is and how the display handles static images. So for example, on an OLED like we have behind us here, if we fill the screen up all the way with the test pattern, the power supply of the TV knows that the entire screen is filled up and tends to kind of dim down the image, versus using a smaller patch where it's the luminance readings and stuff are more accurate to what's real. And we've seen this going back all the way to plasma, right? That's why we used to use like ABL type test patterns for plasmas, right?
Yep, absolutely.
Yeah, good. And I've seen in a lot of other cases also, David, where so there's some TVs out there, consumer TVs, that have local dimming that you cannot turn off. So in some of those cases, you do want to fill the screen up all the way. That way, the TV doesn't try to dim the picture because it sees a small 10% window with a black background. So hopefully that answers that question. Feel free to type a follow-up there if you have one. Sylvan says, is it possible to download, let me open this up so I can see it better. Steve, is it possible to download a profile probe from Lightspace in color space?
Yeah, I mean, we are not guaranteeing compatibility because we don't know if trying to do so will limit what we're doing with color space. Having said that, at this precise moment in time, it's all compatible. That may not hold true going forward, and I'm not going to guarantee it.
Okay, good, excellent. Okay, I think we're caught up on questions. If you want to keep moving along there.
Okay, yeah. Realistically, we've covered the basics of the way the system works. Obviously the big part to a lot of this has been the ability to map information in a greater volumetric form. This all came from, let me just toggle that. I know what that is. Come on. Thank you. Right, this all came from these graphs originally, which are the cube graphs for lookup tables. So this is a graph that shows us the correction that is being applied to the display to compensate for its errors. Now, in this case, most of the errors are purely that the gamut of the display is much bigger than our target, which is why the cube is, in the majority part, smaller than the surrounding box. The one area that's different is the blue, because this display could not make blue. And if we look at the profile of that, we can compare the two, and you can start to see how the different displays react with each other. So, actually, I did the wrong one. I want that is what I want. And if we look at this in the CIE diagrams or whichever, you can see that if we zoom right into this, I won't make the window bigger, but I will zoom in. And if we select Rec 709, there we go. Turn off the tangents, because for this one, they're slightly in the way. There we go. So you can now see that this display, while it has a lot of blue, it's the wrong color.
It's not the right blue, yeah.
Yeah. So when we build the lookup table is attempting to compensate for that but it can't, because the display physically just can't do. It's another one of those little bugs we've still got. It disappearing. Come on, come back. Oh, the lag on this cursor is annoying. Come on. Oh,
I can grab it too and try if you'd like to.
Well, I'll just hold it there for a second. It'll do it. It's just an update. There's, yeah. Okay, just drag the top and make it slightly taller or shorter. There you go. There we go. Perfect. It's just an update. I keep forgetting about that. But yeah, so you can see that the lookup table is attempting to push blue to be greater saturation, but it can't.
Right.
But so it means that you can start to understand what the different displays are showing you. And then when you start to look at that volumetrically, then everything starts to become a little bit more aware, because in this instance, I need to just update the luminance. There we go. You can see here now that we are low in blue.
Right.
And that equates to the fact that blue. Yep. So you can start to really understand underlying display issues far greater than was possible with previous, graphing systems in calibration software.
Sure. Another question came in from Kevin. This is actually a great question. This is a really good question from Kevin. What about reports, like a before and after? Will there be a variety to choose from, and can you do custom reports?
They will. They are not there at the moment. If you look here, there is the report button.
It is on the to-do list though.
Yeah, that'll pop up a new window that will have all the various options for customizing and selecting which graphs and all the rest of it. It isn't there now. It will most likely not be there in the first full release.
Okay.
And again, one of the reasons that some of these bits we are kind of being less urgent about is that we actually do want more user input. The alpha team are doing a great job looking at actual bugs and feeding back issues that are very obvious. When we start getting into the more esoteric kind of controls as we go forward, we need a greater volume of feedback. So we are deliberately holding back on things to see what people say. This is how we'd like it to look. This is how we'd like it to work.
Sure. So, the potential of what those reports can do or show is just going to be based on what the calibrators are asking for.
Yeah, pretty much. I mean, there's a level of understanding as to what's needed,
sure.
But it's a question of the layout, the style, the way that the ergonomics work in selecting it. So yeah,
Great.
But it's all there. It's just not there, if that makes sense.
No, sure, definitely. Okay, cool. That's it for questions so far. We've got about 10 or so minutes left, Steve. So keep moving along and let's keep looking at
I mean, taking things further, I mean, we've been looking at things like, I mean, this is a graph that I really enjoy because it winds people up. At the minute, we don't have what we would classify as a standard EOTF error graph. Our standard EOTF obviously plots the actual curvature against the plot. So if we zoom into this, then obviously you can see that the white line is the target gamma, in this case for Rex 709. If we make it something else, you'll see the difference, so 2.2. And this shows you the gamma error in red, green and blue, the three channels compared to your target. That's all good, but one of the beauties of the differential graph that we have is that it is plotting the differential error, the difference between your target gamma EOTF and what has actually been measured. So rather than this saying, oh, I'm looking at Rex 709, therefore this center line is 2.4, it's saying that line, as the center line is 0, my error is -0.1, -0.2 in bright, going brighter, or the same going darker. Now, with a pure power law, it actually makes no difference. You could substitute those numbers for 2.4 in the middle, and then 2.3, 2.2 going up, and obviously the opposite way. But when you come to things like PQ, HLG, BT1886, they are not gammas, they are EOTF.
Right.
Because they are not a power law. And if you were to try to plot that information, you couldn't have that center line as being the target gamma because it varies. So we just normalize it. So if you were to pull up a plot that was profiled against, PQ or HLG, the graph here would be exactly the same. It would say this line is the target for whatever EOTF you have selected, and any error as a differential will be shown as an offset from that line. And
it based on the scaling of this graph.
Yep.
I've got the increments are teeny tiny. They're in tenths. So 0.1,
yep.
0.2, 0.3. Is there a way to rescale that graph to reshape or resize the
Again,
the
there
errors?
will be. It's fixed at the moment because it's easier to make it fixed. I mean, obviously we can zoom in and out. You can even, it will actually move to wherever the line ends, so you can get to it. But yeah, we've locked those increments at the moment.
Michael asks, what are the vertical units? But I think you just answered that. Michael, if not, feel free to retype into the question box and we'll readdress.
Yeah, the vertical units are EOTF units as difference.
Perfect.
So again, if that was 2.2, that would be 2.1.
Right. So in reality, if the EOTF or the gamma in this case was perfect, we would have red, green, and blue smashed against the zero line.
Absolutely. Yep. You got it.
Great.
You got it. And we run the graphs this way up very, very deliberately because effectively the effect of gamma of EOTF is inverted. As the value gets smaller, the display gets brighter. So we very deliberately run them this way up because it matches this graph. Because if you look here, and if we just, whoops, here we go, zoom into the lower part here, you can see that we have the gamma being brighter, because it's a lower value, whereas when we go to this side, it's gone the opposite way. It's now lower, as in darker. So and we have deliberately, we plot our other graphs to match that. So you can see here that at the beginning, the display was brighter.
All too bright, and then it's all too dark
at the end.
Great, that's cool. Good. And
there we go.
Okay, cool. We are caught up on questions.
Okay, another graph.
5 or so minutes left, so feel free. Show whatever you like to do.
This is the other one that is unique to light illusion, which is the RGB separation. And this actually shows you the ability of the display to respond well to cross color. In other words, if you have a set value of red, green, and blue, does the grayscale match the individual values of red, green, and blue? If you don't have that, you've got cross-color contamination. So in other words, red is affecting the green channel or blue is affecting the red channel or what have you. And this graph basically shows you if the display suffers from those issues or not. Nearly all LCDs will have a little bit in the lower end because as the brightness drops, the gamut reduces. So there will be an amount of that in nearly everything, whereas a good OLED would have none of this, except OLEDs are inherently suffer with cross-color contamination. So actually OLEDs will have a different graph that will be slightly worse in different ways.
Got it.
And very much so with WOLEDs, because of the white pixel, you're going to end up with them being very non-additive is the best way of describing it.
Good, very good. I've noticed a lot with those too. I mean, I own two two white based OLEDs, and there's major differences in the color gamut between the day mode and the night mode just from having the OLED light brighter. As you go brighter in those TVs, the color gamut just gets smaller, and you can see it in skin tones all day. You can see it in skin tones.
No, it was an idea. It makes perfect sense as a way to increase brightness in a technology that inherently doesn't do bright.
Right.
So I get it. it's just not the be all and end all that people seem to want to try and make it out to be.
Sure.
But again, it depends what people want. You know, as we said in our earlier session today, there is no such thing as a perfect display technology.
Oh, no way. Of course.
They
Yeah.
all have issues. You've got to decide which issue is one that you're happiest to put up with.
Yep. That's exactly it. I get this question all the time. I'm sure you do too, friends and family. Hey, what TV should I buy? What's the best?
Yeah.
I'm like, oh, do you have an hour? Because it's going to take an hour to talk about this.
Yeah.
Yeah. No, that's cool.
No, it's very much the case. But yeah, you know, we're getting there. The technology is moving ahead quite interestingly
Sure.
at the moment. So
guys, we're running up on our hour here. If you have any maybe last minute questions for Steve, we could probably go for a couple more minutes. So feel free to type in any maybe last minute questions you have here. Daniel says, same as LED lights, Steve, in virtual production, cross-contamination issues, even in 9 bank clusters of RGB LEDs.
Yep. Yeah, again, to get away with that, you start having to look at individual LEDs that have got very narrow bandwidth,
Sure.
Spectral bandwidth. And then you have other problems, because then you start getting into metameric issues, because, you know, the human visual system isn't geared to that. So, you know, nothing's perfect.
That was such an eye-opening thing for me when I bought my Jetty 1511 last year. I spent probably a day or two just totally geeking out, and I was going around my house and just, you know, it's got a screen on it, right? So you can just tap the button and look at the reading and look
Yep.
at the spectral response.
Yep.
So I was out like reading my taillights of my car and just reading everything I could, and you could see all the ones that were LED based, all the lights that were LED based just had these really, really sharp peaks.
Yep.
Yeah, very, very cool, very interesting.
Yep.
Siegfried says, great webinar. Steve, please make training webinars for color space. Michael says, is it a good practice to update? Is it good practice to update luminance before every profile?
That's an interesting question, actually. Yes, it is, because it means that the target, we always populate this data with something, so that you've got something to start with.
Right.
But the minute that you read another black or white patch, it will update the profile. So it's you know, that's cool. But yeah, my personal preference would be to use the auto function here to just update the min and max. If you're doing manual measure, in fact, let's just connect to that probe again. Yeah. If you're doing things manually, then there we go. You don't necessarily know what colors you're going to be working with. You know, trying to plot your EOTF gamma, what have you. And if the display is variable, for example, in HDR type displays, then you may have updated the black and white to start with, but obviously they have changed because the display just isn't that stable. So we just got an auto box here. If you click that, then every time you measure a black and white patch, regardless of where it is in your measurement cycle, it will update your target data continuously.
So your baseline is always the same. It's not
baseline. Well, the baseline changes with the display changes.
Right. Okay. Gotcha. Yeah. Gotcha.
Yeah. So, but you have the option. You can have it on or off. I mean, you know, if you are using something more stable, then my preference would be to just click that up arrow every now and again when you feel like you want to update it.
Cool. And one last question. It looks like it came in a couple minutes ago, actually, from excuse me if I'm mispronouncing, but from Ladislav, I think is how you might say it. He says, is there an option for a JVC 1D lookup table?
Yep, absolutely. Once you've made a lookup table, they all appear in the library under this working, oops, he says closing it. Let's open that again. There we go. Okay, you see this, we have this thing called working LUTs. We do not intend to save lookup tables inside the software, mainly because they chew up huge lumps of memory.
Sure, absolutely.
So in any session, the LUT will appear here, and then you can use that to view it. So if we double click it, it will open that LUT up in the LUT tools. There's our crazy LUT from earlier.
Oh, yeah.
And then when you want to export, then you select from the drop down the particular one you want. So JVC, is it gone?
A little lower.
Yeah.
Down, boom.
Way up, one. There we go. There you go. And then over here, you have, if there's more options, then there'll be more options for that LUT format. And
Great.
hit export, and it will export it.
Excellent, excellent. Kevin says, thank you, Steve, for an informative webinar. Guys, that looks like that's probably the last comment or question that's rolled in the past few minutes. So with that being said, Steve, thank you so much. This was excellent. I learned a lot myself. Again, this is a new program for me to kind of play around with. Before we cut everybody loose for the day, do you have any kind of final thoughts or words, and how can people get a hold of you?
Email is the easiest, steve@lightillusion.com. That information is on the website, as is a contact form. We are well known for our response to requests for information, what have you. There is also a forum on our website, obviously, for anybody interested in anything that we're associated with.
Excellent, fantastic, guys. Well, that looks like that's it for the day. I don't see any more questions coming in. If you do think of any questions, later today or something, feel free. You can always reach out to Steve. My email address is jason@avproglobal.com. So thank you guys so much for hanging out with us this afternoon. Thank you so much, Steve. And we'll see everybody on the next webinar. Stay tuned.
Thanks a lot, mate. Cheers.
Thanks.